So hello and welcome everyone. So in this video we are going to solve the question make matrix beautiful. So first of all let's try to understand the problem statement. So in this question you will be given a matrix and what you have to do, the dimension of the matrix will be n cross n. So we have to find the minimum number of operations that are required to make the matrix beautiful. So what is a beautiful matrix? So the definition is given to us. A beautiful matrix is a matrix in which the sum of elements in each row and column is equal. And we'll be given the matrix and we have to make it beautiful. So what you have to do, you have to apply the operation. And what is the operation? In one operation you can increment the value of any cell by 1. So that is the operation. And what you have to do, you have to make the matrix beautiful in minimum number of operations. And whatever is the minimum number of operations, you have to print in the output. So now let's try to understand with the help of the test case. So over here I have taken the same example which is given to us in the input, and this is the input number 1 and n is given to us 2 and this is the matrix. So let's find out first of all what is the sum of each and every column and each and every row. So for this row the sum is equivalent to 3, for this it is 7, over here it is 6 and over here it is 4. So now in order to make the sum of rows and columns equal, I need to increment any of the cell and I need to increment the sum of the row and column, right? So what I'll be doing, if I increment the sum of this cell by 3, so basically if I make this 4 and if I apply plus 1 to this, so this cell will be now equivalent to 3 and this cell will be equivalent to 4, and hence the matrix will become 4 3 and 3 4. So the sum of the first column will be equivalent to 7, second row will be equivalent to 7, and over here also each and every column will have some 7. So how many operations did I apply? I converted 1 to 4, so that is I applied 3 operations and I converted this 2 to 3, so I applied 1 operation. So in total we applied 4 number of operations, right? So that is going to be the minimum number of operations, and now this matrix becomes beautiful. So let's try to find the answer for the second test case. So let's first of all calculate the sum of every row. So this will be equivalent to 6, 3 plus 2 plus 1. It will be equivalent to 9. This will be equivalent to 6. And over here, this will be 7. This will be equivalent to 6. And this will be equivalent to 8. So now what I'll be doing, I'll be trying to convert each and every row sum and each and every column sum to 9. So now what I'll be doing, now I apply the operations on this, and for applying the operations, how many, what I'll be doing, I'll be converting this 6 to 9. So I need to apply 3 operations on this row. Now for this row, I need to apply 0 number of operations because I'm converting the sum of every row and column to 9. And for the last row, what I'm doing, I will be needing 3 operations. And for this column, I'll be needing how many operations to convert it into 9? I need 2 operations. For this column, I need 3 operations, and for this column, I need 1 operation. So now basically we'll be focusing on how many operations do we need to apply. So now for each and every column and for each and every row, this is the count of operations I need to apply. So if I convert, so now this is the number of operations which I'll be applying, right? So if I apply plus 1 to this and if I apply plus 2 to this, the matrix or the cell will become 4 and this cell will become 2. Now what I'll be doing, I'll be applying plus 1 to this cell, so this cell will become 3, and I'll be applying plus 2 to this cell, so this cell will become 3. So now I can see that the sum of this row will be 9, the sum of this row will be 9, the sum of this row will also be 9 because this has been replaced by 2 and 4. So that will be 4 plus 2, 6 plus 3, 9. So basically each and every row and each and every column will have sum 9 after applying plus 1, plus 2, and plus 1 over here and plus 2 over here. So basically how many operations were required? I applied 3 operations on this row and I applied 3 operations on this row. So in total I applied 6 number of operations. Hence the output for this test case comes out to be 6. So basically you have to find out the minimum number of operations required and make the matrix beautiful. I hope you got the idea about the question. So now let's focus on how to solve this question and let's see what is the intuition behind it. So now let's try to understand what will be the intuition. So first of all, I'll be explaining with the help of test case basically on which row and on which column we need to apply the operations. So I'll be taking the same input test case number 2 and I'll be focusing on how to solve this test case number 2. So for the first row, what is the number of operations? So what is the sum of this first row? I can see the sum is 6. For this, the sum is 9, and for this, the sum is equivalent to 6. For this column, the sum is 7, 6, and 8. So now let's find out the number of operations. So as we have to apply minimum number of operations, so what I'll be doing, I'll be taking the maximum sum among all the rows and among all the columns. So the maximum sum among all the rows and column comes out to be 9. So what I'll be doing, I will be converting each and every row sum and each and every column sum to 9. So now let's try to find out what are the number of operations I need to apply on each and every row and in each and every column. So in order to convert this 6 to 9, I need to apply 3 operations. For this, I need to apply 0 operation. For this, I need to apply 3 operation. For this, 2 operation. And for this, I need to apply 3. And for this, I need to apply 1 operation. So now we'll be completely focusing on the number of operations. So now let's erase this part. And let's completely focus on the number of operations that we need to apply on each and every row and column. So this is the number of operations required. So now, if you pay proper attention, let's say, if I am targeting, let's say ith row, let's say for the ith row, I need to apply xi number of operations. And for, let's say, jth row, I need to apply yj number of operations. And let's say for some ith row and for some jth column, the value of operation is equal. So over here in this example, you can take the example of this row. See, over here in this row and in this column, you can see the number of operations are equal. So what you can do, you can find the intersection of this row and column. I can see the intersection of this row and column is at this cell. So if I increase this number by 3, that is I apply 3 operations on this cell, then the sum of this column will be equivalent to 9 and the sum of this row will be equivalent to 9 simultaneously. So basically, whenever you find ith row and jth column having same number of operations, you can apply the number of operation either on row or on column. So basically, you don't need to work simultaneously on row and column. You can either apply operations on row or on column. So whenever this kind of condition is encountered, just apply number of operations on column or row. So in this manner, we'll be working either on rows or either on columns, but we'll be not working simultaneously or not applying number of operations both on rows and columns, because row and column, both of them will be intersecting, right? So we don't need to apply operation. If you are applying the operations on rows, then that is going to already affect the sum of the columns present inside the matrix. So now, in order to solve this question, what I'll be doing, I will be simply finding out the number of operations that are required on every row and every column. So let's say I have created 2 different arrays. So I'll be creating 2 different arrays, and the first array will go by the name row and the second array will go by the name columns. So this row and column will contain the number of operations that I need to apply on row and column. So this is the 0th row, 1th row and second row, right? So this is 0, 1 and 2 column. So what I'll be doing, row number 0 needs 3 operation, 0 operation and 3 operation. And for column, I need 1 operation, 3 operation and 2 operation, right? So now what you can do in order to find the answer, you can simply focus on finding the sum of all the elements inside the row array or all the elements inside the column array. And let's say the sum of the elements inside the row array comes out to be 6, and over here also it comes out to be 6. So basically, you can find the sum of row or sum of column array, and whatever is the sum of the row array, just print it in the output, and that is going to be your solution. Because both of them, if you apply a number of operations on row, then that is eventually going to increase the sum of each and every column. So basically, just find out the sum of elements present inside the row array. So that is the entire solution, and the solution was pretty simple. Just a simple intuition was required and simple observation was required based on the test cases. I hope you got the idea about how to solve this question. So now let's try to focus on writing down the implementation part for the same. So over here, I'll be coding the implementation in Java, but the same can be implemented in other languages as well. So let's start. So first of all, what do we need? We need 2 arrays, row array and column array. It will be storing the number of operations required, right? So what I'll be doing, I'll be storing the sum of every row in the row array, and I'll be storing the sum of every column in the column array. And then I'll be finding the number of operations. So first of all, let's try to find the sum of every row and every column and store it inside the row and column array. And along with that, I'll be finding that among all the rows and among all the columns, what is the maximum sum. So for that, I'll be needing a maximum sum variable as well. So let's write down. So first of all, I'll be creating maximum sum variable having value equivalent to 0. And now let's write down row array. It will be having size equivalent to n because the size of the array is n cross n, right? And now let's try to iterate over each and every element. And row of I will be equivalent to, I'll be adding the value matrix of I comma j at the ith index inside the row, and for column of j I'll be adding matrix of I comma j because that element will be present at the jth column and I comma jth element will be present at the ith row inside the row array. So I'll be adding at the ith index inside the row, and I'll be adding at jth index inside the column array. And along with this, what I'll be doing, I'll be finding the maximum sum. So whenever I find the sum, what I'll be doing, I'll be comparing it with the maximum sum variable, math.max row of I and maximum. And over here as well, maxsum is equal to math.max column of j and maxsum. And now each and every row array and each and every column array contains the number of. So now over here, after this loop, the row array will contain the sum of every row and column array will contain the sum of every column. So now I need to find out number of operations. So for each and every index, what I'll be doing, I'll be subtracting the value by maximum sum. So let's iterate over each and every element of row array and column array. So row of I is equal to maximum sum minus row of I. So this denotes the number of operations required on ith row, and column of I is equal to maximum sum minus column of I. This denotes the number of operations for the ith column. And now what I need to do, I simply need to add the summation of number of operations from the row array or from the column array. So I'll be creating one more variable, that is the answer variable, and I'll be adding the value of either of the row array or the column array. Over here I am choosing row array, but you can go with the column array as well. And there is no requirement of finding the column array if you are only going to consider the row array. You can completely erase this part. But for your understanding, let's comment this part and let it be as it is. And if you are going to consider column, so you'll be writing in this manner, answer plus I is equal to column of I. So now this means you will be adding the values of column array. And at the end, you simply need to return the value of answer array. And that's it. And let's try to compile and run. So over here we made a minor mistake, just change the argument as small n instead of capital N. And we can see that the compilation is successful. Let's try to submit it and let's see the acceptance. And we can see that the problem has been successfully submitted. So this question was pretty much easier to understand if you try to focus more on understanding how the examples can be solved. And now talking about the time and space complexity, if you observe carefully, there is a nested loop over here. So the time complexity of this approach is going to be order of n square. And over here there is a linear loop, so this will take order of n. So basically overall this algorithm is going to take order of n square time complexity. And what about the space complexity? So I have used two extra array, row array and column array, and both of them are of size equivalent to n. So the overall space complexity comes out to be order of n for this approach, and this completely aligns with the expected time and space complexity mentioned inside the question. I hope you understood the logical implementation and intuition part for the question Make Matrix Beautiful. So that was it for in this video. I hope you really enjoyed this solution. And if you really enjoyed this solution, do hit the like button and share it with your friends. And do subscribe to this channel. Thank you.